Hello and welcome folks to a new video. So this is going to be a little bit of a demo, a little bit of a sort of a tutorial video. Um, so background on this, I've been working on a good few electronics projects recently, and there's something that I've been doing quite a lot of, which is making my own components in Autodesk Fusion. And I realized that it was something that took me ages to actually get around to doing it, and doing it using the tools that are built into Autodesk pretty well, or into Fusion pretty well, and also just something to kind of get my head around, because to someone who doesn't have, a formal training in this stuff, it's a little bit dense and it's kind of a little bit difficult to get into. So this is when I was first designing my very first ever PCBs. I found this really hard to figure out, well, how do I know what parts to use? And if I know what parts to use, how do I find, the models to put them into my schematics? And then, going further than that, how do I know that, my supplier is even going to have these parts and all this sort of stuff? And there was just this whole chain of different questions in my head that I couldn't really answer very well. But one of the difficulties then as well was once I started to figure out the supply chain and what parts my supplier had and all that sort of stuff, one of the big stumbling blocks I still had was actually getting the parts into my CAD software so that I could then reference them properly and have them set up the way I wanted them to get them onto my PCBs that I was designing. So I've discovered how to use these tools a little bit better, and I'm hoping that I want to share that with you guys now, and I'm hoping that this helps someone understand a little bit about how the design process works and show you a little bit about how it works in Autodesk Fusion if you haven't seen that before. So let's start at the start. We got to figure out what part we want to use. So for this example, I'm just going to spin up a custom package for a single part. That's actually something I'm using in an upcoming project. I'm going to put it into a parts library here in Fusion, and I'm going to put it onto a PCB and just show you what that all looks like end to end, basically, and how I think about it. So start off, need to have a part. So for me, I'm sponsored by JLC PCB. You'll see that in a lot of my videos, and I've been using them for a long time. One of the things that I love most about them is that they have this really nice parts library online, so you can go and you can search for parts and you can see what's in stock. So that's an important thing, because you could find an endless supply of different sort of parts that exist in the world to do all sorts of different things. But you need to actually be able to get that part, or your supplier, the person who's manufacturing your PCB, needs to be able to get those parts so they can assemble them onto the PCB if you're doing a full end-to-end design and assembly process, which is something I do because I'm not really set up to hand assemble complicated boards and stuff myself. So with that said, you get your part, then what do you do with it? You need to be able to put it into your CAD software. So in Autodesk Fusion, the way we do that is we use an electronics library component. So this is an empty one I've just spun up, and an empty electronics library I've spun up for this example. In Fusion, you can go up to File, a new electronics library to start this off, and you'll end up with this thing, which is completely empty, doesn't have any components in it or not. We want to put a component into this. So I should say there are existing libraries that exist that have like all this sort of stuff in them, but you may not be able to find one with your exact part. So there's a bunch of different ones that exist for loads of different suppliers, manufacturers, all this sort of stuff, but you may not be able to actually find the ones you want. And also you have no idea if some random one that you download off the internet is actually correct or not. If the things are wired right, if the pins are right, if the layout's right, you don't have any idea really. So it's safer and better to make your own ones. With that said, let's have a look at the part that we're going to be making. So it is this guy, which is an FP6291, which is a DC to DC step up boost converter. As you see, it has like a little diagram here. Put voltage in and you'll get a voltage out that's higher. So you say put the application I'm going to use this for is I'm going to boost the output of an 18650 lithium ion battery from 3.7 volts to an output of 5 volts, which is generally useful for electronic stuff. So anyway, the important part isn't the circuit diagram in this case. We want to know about the package that it comes in. So this is the actual chip that it's going to be and how that sits on a board and what it looks like. So there's a lot of different types of this, so I'm kind of going to jump around a few places. So there's parts of this that you'll need to know, parts of it you won't need to know. But anyway, the first thing you need to know about creating a one of these is you need to know what package it is physically in. So there's loads of different packages. Chips come in all sorts of different shapes and sizes. There's through-hole components. Surface mount is mostly what I'm interested in, so I will tend to try and find chips and stuff like that have surface mount packages, which most do these days. So if it's not obvious, we have here in this one, we have it called out, the package that it is, and we see it's a SOT 23.6. So if that doesn't mean anything to you, that's fine. If we scroll down, we can find a version of it. So this might mean a little bit more to you, a chip that looks like this. So this is what a SOT 23-6 looks like. It's a little 6-pin chip, which is kind of like the sort of long, thin rectangular pieces with the 6 pins, 3 on either side, all nicely evenly spaced out. So we know that when we're creating our part in our design library here, the first thing we need to start with is a SOT 23.6. And that's what we're going to use as the basis. Come back to me. Where's it gone? There we go. So let's have a look then. See, is there any other information in here that we need? So we scroll down here. Here we go. So this is important. This table here is all of the mechanical definitions for the chip itself. So you see this looks like the other diagram we saw, except it's got a bunch of dimensions called out on it, and it has this table underneath here with the kind of min-max style dimensions of this chip. So maybe asking yourself, well, if it's a SOT 23.6, is that not like a standard that just is a standard size and it should fit no matter what, and then the footprint, the pads for it should be identical? And you'd be right in thinking that, but unfortunately, the world we live in, these things aren't quite standardized. They are more or less standardized. There's a lot of the dimensions here you'll see are very similar across different chips, but all the different manufacturers will do ever so slightly different things with their values. So you can't just trust that a SOT 23.6 is always going to be exactly the same. So again, you're better off looking at the datasheet, finding the mechanical information here, and then using that. And I'll show you exactly how we're going to use that in just a second. So anyway, that's enough preamble about what we're doing. Let's get into Autodesk Fusion and let's start building this thing out, and I'll explain a bit more about what's going on as we go through it. So first things first, we want to create a new component. So in my window, I have this button up here in the top left for create new component. It's going to ask me to name that component, so we're going to name it just this. So FP6291, and click OK. And make this full screen. And you see we've got this empty component that has nothing in it. So that's that's great. Where do we go from here? Well, first thing I usually do, give it a little description. So we say this is a DC boost converter. Great. What else do we do? So first thing we need to do, well, the first thing I like to do with here is we need to create the actual package itself. So you notice there's a few options down here. We've got the component, which is just sort of a summarized view of the whole thing. We have symbols, we've got footprints, and we've got packages. So there's a little bit to go into, a little detail in here. So packages in this world in Fusion are the physical packages, like I just showed earlier, like a SOT 23 is a package. In Fusion land, these are basically the models, the like Fusion 360 3D models of the packages themselves, which will be used later on. You'll see if you render a board, those are the models that are used to render the components. They're not super important, but there's one thing that they're very important for in terms of your part library, and that is the footprints. So footprints are the little pads, the layout of the pads that will actually go onto the board. So it's called a footprint, obviously, because you have your component and it sits down onto your board, and it will have, little copper pads that it sits on, and the dimensions of those are critically important because that's what your component sits on, that's what it'll get soldered onto, so they need to be accurate. There is basically a relationship between the package and the footprint. And if you see on the the board. I don't know, does this one might not give it. Some of the data sheets give you the footprint. This one doesn't. But basically, most components will give you an example of, well, this is what the footprints should look like. But in general, the footprints are pretty much associated to the package. So, you know, if you have a SOT 23.6, you need 6 little pads that sit underneath the pins of this. Now, exactly the locations of those you can derive if you know what the dimensions of this chip are. So bear with me, this will become a little bit clearer in a second when I go through the next step. But effectively, if you can build the package, you can know the footprints. And one real key is that within Fusion, it has enough smarts in its brain that when you create a package, it will generate the associated footprint for it, and it will match the chip that you want to put on the board. So there's an amount of trust in there, and it's not 100% perfect, but it's pretty damn good in my experience. So you'll see that in a second. Last part then is a symbol. So this is what goes into your circuit diagram. So when you drag and drop in, you know, like a resistor symbol or a capacitor symbol or whatever, this will be the symbol that gets associated to your chip. I can show you how that works. It's, again, not super complicated. It just involves a little bit of know-how and a few steps. So with all that said, let's make our first package. So make a new package. We'll go down here. So we're on the component. We're in context of the component. So we go down here to this section. We'll click the new and we'll say add a local package, and it'll pop up like this. Oh, sorry, actually, that's wrong. My mistake. That's how we associate one that we've already uploaded. Package. We need a new package. We go up here to the top left and we'll create new package. So now it's dropped us into this this model window, which if you know Fusion, Autodesk Fusion, this is just a standard 3D design window. But what you'll notice is there's this special tool over here on the side called the package generator. So this little tool has a bunch of different types of packages already pre-programmed into it. And what your job now is to pick the one that matches the type of chip that you want, and then we can go from there. So if we scroll down here, we'll see we should find one for a SOT 23, and there we go. So this is a SOT 23. So we'll click on this guy and see what we get next. And next we get this window which has all these values in it. So these should be familiar because it's basically a map of this. So you'll notice we've got the same kind of schematic here, and we have the same kind of schematic here, and we have a bunch of like min and max values. So let's go ahead and match these. One option here, a SOT 23 could be 3 pins. It can also be 6 pins. So let's make it a 6 pin, or different types of pin out. So it's a 6 pin one, we know, because we have 6 pins. So let's go and look at the rest of our dimensions. The other thing, something you have to be aware of, is that these are labeled with specific letters and stuff that denote what the dimensions are. They may not match here. It just so happens that this one does actually match. Yeah, the dimensions are the same. Yeah, which is nice. But they might not. They can use different notations because, again, sort of a standard, but also sort of isn't a standard. They can use whatever notation they want for these in the data sheet. So this one just happens to match, which is nice. So let's do it. Let's match it up. So E here says 2.3. So this is also where it is important to know standards and stuff. So this is saying that a standard for a SOT 23 would be that the width of the overall chip with the legs included is between 2.3 and 2.5 millimeters. In this case, they're actually just telling us it's just 2.8 millimeters. So that's something that we need to take into account, and we need to update that here so that we actually get our chip to fit. What else? So we got L, the length of the pad. So we have the length of the pad, L, that called out here. Yes, it is. And L is, so L does give us a range, 3 to 6. Very similar. And I'm not going to talk through the rest of these. I'm just going to type these in. We'll do a little fast forward or something. Okay, so we have all our numbers typed in. We're ready to go. We click the button, and this will just spin up a little model for us. So let's see. Oh, she's thinking. Really hope this doesn't fail, because that'd be annoying. Okay, and we're back. There's our components, and you can see what I mean now about the package. So this is just a normal Fusion 360 model, and you'll see we've got the little rectangle shape. We have our little feet all set up, and it matches what the picture looked like earlier. But more importantly, what you notice here, which is what I alluded to earlier about the pads, you see these dotted green lines surrounding it. So under the hood, Fusion is going to use those outlines, that drawing, and it's going to create the footprint for us for this component, so we don't have to try and draw the footprints ourselves, which can be a little bit cumbersome because of the tools more than anything. They're quite old, the actual footprint drawing tools, quite difficult. This is quite accurate, and it also means that it matches up with your 3D model, which is very nice. So last step that we do here is we go up to the big green finish button and click finish. It'll ask us to name our part, so we're going to name it the same as we named the other one. I'm going to put it in this little custom packages folder underneath here, just for neatness, and then click save, and that's job done. So that gets linked in here to your library manager. We can see it here. If you click on it, you see the little package here, but it didn't by default associate it with the actual part that we want itself. So what we do is we'll go down to here, go to add a local package, and you'll see this is the package right here that it wants us to add. You'll see the footprint drawn out here very nicely for us, has name, value, all the stuff you'd expect. One of the other cool things is it has the pin numbers all labeled, and it has the little silkscreen dot on it, which is indicates the pin number 1 usually, which is quite nice. So click OK on that, and now this part has this model associated with it, which has a footprint associated. We know it has 6 pads because it has the 6 pins that it connects to. So yeah, that's all pretty nice. Last thing we need to do now, before we can use this, well, second last thing, is we need to add the symbols so that we can wire it up in our circuit diagrams. So to do that, we're going to obviously want to add a new symbol. So the way we do that is we can basically draw a new symbol with this tool. So there's this thing here where we click add, and it'll ask us the same thing to upload one that exists in the library, but we don't have any yet, so we got to go and draw one first. So back up here to our top left again, new symbol, click on this. It'll ask us to give it a name, so you stick with the same naming convention, just the part name. Click OK, and now we're into the symbol construction tool, whatever you want to call it, ECAD thing. So this uses all kind of old school ECAD stuff, which is similar to how the pads are drawn. I don't particularly like doing this type of drawing. I find these tools quite hard to use, but they are kind of very powerful, and they are an industry standard. They're quite old. So they don't have as many of the nice features you might expect from a modern CAD platform. But we don't have to do anything crazy complicated here. Super basic, so let's just roll with it. So what we're going to do is we're going to draw some lines. This is just basically, it's just going to be a square box with 6 pins. That's it. That's all you need to worry about for these. You don't have to be anything fancy at all. So we'll pick a point to start with. We'll start here. We'll go 1, 2. So we'll put a pin there. We'll do 2, put another pin there. So they're separated by 1, 1, 2, another pin. So we got 1. So we got 1, 2, or how we do this? We'll do it now. We'll do it a bit nicer than that. Make it a bit bigger. So we go 1, 2. Do your maths right, Ian. How do I make this pretty? Will that space it out well? I think that'll space it nicely. So I go pin there, yeah, pin there. Okay. And then we'll just close off the box like so. Okay, so there's our little box. And then we want to add our pins. So we go up here to add a pin. And we'll stick one pin here, one pin here, one pin here, and then we'll flip these around, one pin there, one pin there, and one pin there. So that's it. That's our shape. Effectively, we could call this done here, but we'll make it a little bit nicer, and we'll give these pins names to make it a little bit easier when we have to wire it up later. So we'll go to the name button and click on the pin. It'll ask us to fill something in. So if we want to know what we're actually going to fill in, we should probably look at the names that the pins have on the chip. So scroll up to this diagram. There we go. So we have pin numbers here along with names. So let's just match those up. Very quick and easy. Just click and type. So it's LX and pin 2 ground and pin 3 feedback, pin 4 enable, pin 5 is our voltage, and last pin OC. What's OC stand for? Current, operating current. Cool. Okay, so got them all labeled up. That is it. Simple as that. So not too painful. We used the tool, the old school CAD tool, and it worked, and it wasn't too bad. So if that's all you ever have to do with this, absolutely fine. Really not too bad to deal with. That's how I like to keep it. I try and deal with this as little as possible, this type of CAD. So that's all we have to do. It's in there now, so we can just save that. I'd love to save because it's Fusion anyway, and then we go back to our component. We still don't have it actually associated with anything, so if you expand this out, you can see what stuff is associated with it. So in this case, you can see that we have our footprint and our model associated with it, but we don't have a symbol yet. So we go back to the context of this, double click on it, and we need to add our symbol. So we can click this button up here, add symbol, and there's our symbol that we just drew. Click OK, and we can drop that into here. Done. Okay, that's that sorted. So now we have the symbol associated with it. There's one last little step we have to do, and that one last step is that we have to map the symbol, the pins on the symbol, to the pads in the footprint. And that's the last step. And you'll see down here, you'll see that we have this mapped little thing here, and there's a little yellow triangle in it, which is telling us that you have a pad and you have a symbol, but you haven't mapped the pins yet, which is the last step to do. So that's so it knows what to connect to what when you've drawn the schematic, and then generate the PCB from that. So we'll click this. Oh, you can't see, it's underneath my face. I resize this a little bit. Yeah, so there's a connect button here. So we click this connect button, gives us a little pop-up window, and you'll see it gives you the pins here, which are the named pins from the schematic that we have, and the pads, which are the numbered pads from this chip. So we need to associate them, which you may need the datasheet for this as well. So this is another usage for our wonderful data in our datasheets. So that's doesn't scale well when you make it smaller. Move that over. And we click the connect button again, and then have our list appear. So you'll see we have our pins, we have our pin numbers, we have our names, we have our names here, we have our pin numbers. So let's start connecting them up. So we know LX maps to pin 1, so we'll hit the connect there. That one's done, and then we just do that for all of them. So we know our ground pin, which is pin 2. Click connect. We've got our feedback pin, which is pin 3. Click connect. And I think you guys are getting the picture. Pin 4 is enable, VCC is 5, and operating current is 6. Connect, and done. And that's it. So this part, in all its glory, is now ready to use in on a PCB. And that's all. That's all that goes into it. This is ready to go now. It has a little symbol. It has a footprint which will match that part, and has a symbol that you can use in your schematic. So let's just do a little example of what that looks like to use it then, to kind of round things out. This won't be obviously a full thing, but it'll give you some idea. So I've created a little sample project up here, which is just called demo. So this is what I mentioned actually, sorry, before about all the different libraries you have. So these are all built-in libraries that exist, and some of them are some libraries that I've made. So you notice there's a whole ton of these. And these might have some really useful stuff in them. You might be able to use them all yourself, but mix and matching them, no guarantees any of it will really work. So that's why I prefer to do my own ones. So if we go into here, we can go down and find the one that we just created, which is called, what is it called? What did I call my own library? What did I call it? Demo parts, that's what I called it. So this little 3 people means that it's one of your cloud stored ones. And so it has one component in it. So we'll click on this component and we'll see all the details about it there. And we can drag and drop that into our schematic. Boom. All done. Great. Well done, us. But this isn't obviously going to do anything on its own. But we can save it. And then we can go to our PCB view of this. So we switch to the PCB document. And there we go. So this is a blank PCB, nothing set up on it yet, but we'll notice that we have our chip down here. So we can place this on our board, and there we go. So I'm gonna move some of this around just to make this a real small little board so that we can see it a little easier. What's gonna happen in a second? Oh God. Okay, so this is just gonna be a tiny little PCB that will just have a single component on it, just so you can see what it looks like. So that's it. There we go. Have our chip. We have the little footprint of it, 6 pins. It has its silk screen, has its name, and its little symbol, which you can alter all of this stuff. You can just delete them if you want. But yeah, I want to see that that's what it is. So I'll leave that there. And let's move it to the middle of the board. So effectively, that's a little PCB. And yep, we can save that. Save it. We see we have our footprints. And now, if I switch to the 3D view, this is pretty cool. So we'll select everything, click the push button. And there we go. So there is our little PCB. Whoop. And our package that we saw earlier is plonked onto our PCB. We can see we've got our little pads here. We've got our silk screen, and that's the whole thing. So there we go. That's kind of it, really. The other cool stuff you can do with this, you can like hide the board itself. You can hide that. If you go into packages, you can see there's our chip package. You can hide the chip package, and you can see just the footprint there. So there's just the silk screen mask and the actual footprints that will get put on the board, and then that's what it might look like. Should look like with your chip on the board. This isn't necessarily super useful. I like to do this to generate these and look at these to just sort of visualize what I think the final board will look like. And depending on some larger components, maybe you want some clearance between them if you plan that you need to rework the board or something, or if you do have some hand solderable components that you make sure you'll be able to get your soldering iron in around the other components on the board. So it does have some uses, practical uses, but mostly it just looks kind of cool. But the real practical use of actually creating these packages is so that you can get the footprints out of them, and that you know the footprints will be accurate, so that you can lay out your board properly like this and be confident at the end of the day that it'll all wire up, and when your manufacturer goes to assemble these boards, they'll be able to pop the components on the boards. Whew. Okay, so that was quite a lot. I didn't quite expect to talk for that long. I hope this was useful. I hope I haven't just glossed over a lot of stuff and a bunch of this doesn't make any sense. Please feel free to drop any comments or questions down in the comments section. I'll do my best to get back to you. Again, I'm no expert in any of this stuff. This is just what I've learned, what I've put together, and this is how I've leveraged the tools that I use to be able to get me to final results. And I've used this exact process to make boards in the past, and to use my own custom components, and they've always worked in the past when I've done it this way. Not to say that this is perfect and that I wouldn't run into some problems in the future, but this is how I do it. and this seems to work for me up to now. So take that with a pinch of salt. I'm no expert, just some guy on YouTube. But anyway, I think we're going to leave it here for this video. Thank you very much for watching. And as always, guys, I will see you in the next one. Bye.